Hello, algebra students. We're going to take a look at multiplying monomials, section 4.3. This comes from pages 152 to 154 in your text. And we're looking at rules of exponents for the product of powers. So product meaning we're multiplying, and we're multiplying with powers or exponents. So the general rule in algebraic form for all positive integers m and n, when we have a, just any number, to the m times a, any number, to the n, then we can find that value by taking a to the m plus n. So generally the rule then is to multiply two powers as long as they have the same base, then you can simply add the exponents. So that rule is a rule that hopefully you'll memorize, but I'd like to take a look at where that rule is coming from. So some examples here under number 1. We have x to the third, which we could write expanded out as x times x times x. And then times x to the fifth, which we could expand out as 5 factors of x. And so you can see if we expand them both out as multiplication problems, and then if we would just look at that problem and shorten it up, we have 1, 2, 3, 4, 5, 6, 7, 8 factors of x, so x to the 8th. And so the shortcut for that is just to add the exponents when you have the same base, and you get that power of 8. Let's look at that same idea with example B. We can expand b to the 7th out to 7 factors of b. And then we can expand b to the 4th as 4 factors of b. And so if we look at what that is and then we shorten it up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 factors of b, or b to the 11th. So again, the shortcut or following the rule, you're just adding the exponents when you have the same base. So let's look at an example that's a little more complicated. We have 3n squared, and we could write that out as 3 times n times n. And we have 4n to the 4th, and we can write that as 4 times n times n times n times n. And you know, because of the commutative properties of multiplication, that we can change the order and regroup things because of associative. So we could write that as 3 times 4, grouping the coefficients together, and then we can put our factors of n all in one place. So we have our 2 factors of n, and then we have our 4 factors of n, and you can see I've grouped the coefficients 3 and 4. So we can shorten that up once we kind of looked at it in expanded form. That 3 times 4 we know is 12. And then we have 2 factors of n and 4 factors of n being multiplied together. And so altogether that is 6 factors of n, or n to the 6th. So we multiply our coefficients. We're adding our exponents when we have the same base. Let's try number 3. So I have my coefficient of -3, and I have 3 factors of a, and 2 factors of b. I have a coefficient of 5, 1 factor of a, and 4 factors of b. Notice that that a has an exponent of 1, When you don't see an exponent, it has an exponent of 1. We don't want to make the mistake of thinking that there are 4 factors of a there just because the b has the 4. That's a pretty common mistake, so watch for that. Then I can mentally regroup them, and I'm regrouping my coefficients together. And I have my 3 factors of a from the first monomial, and then the 1 factor of a from the second monomial. And then I have my factors of b. And if I put them all together and multiply them all together, I get negative 15 from my coefficients times a to the 4th, b to the 6th. And again, the shortcut would be to just multiply the coefficients, and you're adding the exponents for the same base. Number 4 is a little more complicated. Of course, as usual, when you have a more complicated problem, there's usually lots of different ways you can approach it. So I'll show you mine. And if you have any questions about it, make sure you bring them to your teacher. I have so many factors here, and I have division involved in the problem. I'm going to try to cancel some factors out by reducing fractions. So I'm going to divide my denominator by 3, that gives me a factor of 1, and my numerator by 3, and that gives me 4. So I'm kind of canceling there. I can also cancel by dividing the 5 by 5 and getting 1, and dividing in the numerator, dividing the 20 by 5 and getting 4. You can only cancel like that if you can cancel something in the numerator and something in the denominator. And that just makes my fractions a little smaller to deal with. It also makes my denominator 1, which is nice. So now I'm going to multiply my coefficients, and that's 4 times 4, which gives me a coefficient of 16. The next thing I'm going to do is look for matching bases. And I have a matching base of x. I have x squared times x to the 3rd. So I'm going to use my shortcut rule and know that if I have the same base, I can add the exponents. So that gives me x to the 5th. Then I have y's of the same base, and remember the y with no exponent really has an exponent of 1. And so that gives me y to the 1st times y to the 5th, which is y to the 6th. The next problem is more complicated, and we're going to tackle it in a couple of parts. I'm going to look at one addend and then the other. So I'm going to start by multiplying my coefficients, and 3 times negative 2 gives me negative 6. Then I look for my same bases that I'm multiplying, and I'm multiplying x to the 4th times x squared. And that gives me x to the 6th. My next matching base are the base of y, and I have y to the 6th times y to the 1st. And that gives me y to the 7th. Then I notice I'm adding that to the other addend, and I want to go through that process again with those. So I want to multiply my coefficient. This time my coefficient of the second factor is just 1, so that gives me 8. And I have x to the 3rd times x to the 3rd, which is x to the 6th. And y squared times y to the 5th. I add the exponents, and I get y to the 7th. And I hope you'll notice that these are like terms. They both have x to the 6th, y to the 7th. Like terms have the same variables to the same power. Now we cannot add or subtract unlike terms, even though we can multiply and divide unlike terms, but we can add like terms. And since these both have the same variables to the same power, we can add them. And so we're going to add our coefficients of negative 6 and 8. That gives us a coefficient of 2. and the exponents and their bases stay the same. So it's like I have -6 of something, and I'm adding it to 8 of something, and I get 2 of that something. And that something happens to be x to the 6th, y to the 7th. Notice that the exponents stay the same when we're adding the like terms. So we want to find the perimeter of the figure. So some of the sides are labeled, but some of them are not. So we need to decide what those sides measure before we can find our perimeter. So we have this long side of 4a, which is going to match the side opposite. So I'm going to write 4a on that side. And we have this kind of the top of what looks like an H. Each of those are A. And so the bottoms of the H would also be A. We have the inside sides of the H being A. And so across from that would also be A. And then we have the kind of inside bottom, which is A, and that would match the A across from it. Because the long side is 4A, and then the inside of the H is A here, and we have this being A as well, these two inside on the bottom shapes would be A also. And then looking at those measurements, we should be able to determine that this part is 2A because it's the long length of 4A minus the 2 A's that are labeled. And so this would also be 2A as well. So now we have all our measurements on the figure. Let's take a look at perimeter. To find our perimeter, we're just going to add our way around the shape. And so for perimeter, I have the two long sides of 4A and 4A. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 other sides of A. So all together, I have 18A as the perimeter. All right, so I cleaned up the drawing a little bit so we can take a look at area. For the area of the figure, I have 3 different rectangles. I have a rectangle that has a length and width, a length of 4A and a width of A. So to find that area, I would do 4A times A. And then I have to add that to the area of the middle rectangle. Now the middle rectangle has a length of 2A and a width of A. 2A times A for that area. And then I would be adding to that the area of the third rectangle. And that rectangle has a length of 4A and a width of A again. So length times width will be 4A times A. When I shorten those, I get 4A squared plus 2A squared plus 4A squared. Now because I have like terms, again, I have the same variables to the same power. that means I can add those together. So I have 4a's squared and 4 more a's squared and 2a's squared. So altogether, I have 10a squared for area. For the next problem, we want to find the surface area of the rectangular prism. So we need that formula. The surface area of the rectangular prism is 2 times the length times width plus 2 times the width times the height plus 2 times the height times the length. Now you could just find the area of all the faces and add them together. I'm going to show you following the formula. So we have our surface area, and that's 2, and I have the length as 3a times the width of a, and we would add that to 2 times the width of a and the height of 2a, and we would add that to 2 times the height of 2a times the length of 3a. Now we want to simplify each of our addends. So we would get the surface area is equal to, and 2 times 3, we multiply our coefficients first, and that's going to give us 6, and then we have the same base there, a squared plus 2 times 2 gives us 4, and we have 2 factors of a again, a squared plus, and here we have 2 times 2 times 3, so that gives us 12, and a times a is a squared. Now again, we luckily have like terms, and when we have like terms, the same variables to the same power, we can add them all together. So we end up with our surface area, and we add our coefficients of 6 and 4 and 12. That should give you 22, and that's 22a's squared. Make sure to bring your questions about these notes into your algebra class and ask your teacher.